Hi everyone, welcome back to Dave's Math Channel. I'm your host David Tear, and today I'm going to do another number theory video. This is a follow-up to the one I did last time on amicable pairs. Today I'm going to talk about three very closely related types of numbers known as perfect, amicable, and sociable numbers. I already have two videos on perfect numbers and amicable numbers, so I'm not going to go into those in detail today. If you want, you can watch those videos I already made. But anyway, let's begin. So let's first define these things: perfect, amicable, and sociable numbers. Well, uh, they all have very similar definitions in terms of the sum of the non-trivial divisors of n. So we let S of n denote the sum of the non-trivial divisors of n. If you like, it's just the sum of the divisors of n minus n because it doesn't include n itself. Um, and we say a number is perfect if S of n equals n. And I think you guys probably know about perfect numbers. The smallest four perfect numbers is 6, 28, 496, and 8,128. And they're very, very rare. I mean, there's only 51 that are currently known. And the largest of those has over 50 million digits. So they're very rare and they're very hard to find. And it's not known whether or not there's infinitely many. I think it is believed there are infinitely many, but nobody's proven that yet. Anyway, let's move on. So, what about amicable numbers? Well, amicable numbers just means that if you calculate S of n, that means the sum of the divisors of the sum of the divisor of n, that does equal n, but the sum of the divisor of n itself is not equal to n. So if you like, amicable numbers come in pairs, n comma m, where S of n equals m, and S of m equals n, where m and n are not equal. And these are also kind of rare. I talked about these in the last video. Smallest amicable pair is 220 and 284. They're not that rare. They're not anywhere nearly as rare as perfect numbers. There's already over a billion known amicable pairs, and the largest amicable pair, each number in it, has over 50,000 digits. So, um, they're kind of rare, but they're not nearly as rare as perfect numbers, and it's not known whether or not there's infinitely many. Most people suspect there are. Finally, we get to sociable numbers, and this is kind of a continuation of the same idea. So, sociable number is a number n such that when you compose S with itself some number of times greater than 2, we call that k. If you like, that's the chain length. So we say sk of n. That means S of S of S of n, where you compose S with itself k times, is equal to n. So if you like, there's a chain of length k. You can the first number you can call n1 if you like, or n0. I prefer to call it n0. And then you can say S of n0 is n1, S of n1 is n2, so on, all the way up to S of nk minus 1 gets you back to n0. And each number in this chain of length k, they're all distinct. So that's what a sociable number is. And like amicable pairs always come in pairs, sociable numbers always come in chains of length greater than 2. And there aren't very many sociable numbers that are known. As a matter of fact, there's only 6 known lengths of sociable numbers. The only known chain lengths are 4, 5, 6, 8, 9, and 28. There's no sociable chain known of length 3. It's not known whether or not they exist. I don't think it's known whether or not any lengths other than the ones I've listed exist. So not too much is known about. And there's not too many sociable chains that are known. I'll give you some statistics. Here's some statistics. So this has actually perfect, amicable, and sociable numbers. This kind of sums up pretty much everything that's known about them. So like I said, there's 51 known perfect numbers, the smallest of which is 6. There's over a billion. Here's the exact number. I guess 1,225,000,000. I'm not even going to read this number off, but it's a big number, over a billion. and these are amicable numbers now. And the smallest amicable number that's known is 220. Like I said, they go up to 50,000 digits, the ones that are known. And then length 4, it turns out there's a lot of amicable chains that are known of length 4. Not nearly as many as, sociable chains. Not nearly as many as amicable numbers. Length 4 seem to be pretty common. I'm not sure why. There's over 5,000, I guess exact number is 5,398 currently known sociable chains of length 4. And the largest number in the sequence of, I guess, the smallest amicable known sociable chain of like 4 is 1,264,480. So the numbers are pretty big, these chains. And 5 is kind of interesting. Actually, like I didn't mention this yet. I'm going to talk about there was a Belgian mathematician named Paul Poulet who discovered the first two known amicable chains or sociable chains. One of like 5 and the other of like 28. There's only one of each of those that are known, and the chain of length 5. I guess these are the smallest numbers in the chain actually. So the smallest number in the smallest known chain of length 4 is already over a million, and the smallest number in the smallest known chain of length 5 is 12,496. And I think he just found this number by trial and error. You can do a computer search nowadays, but Poulet found this in 1918, way before there were computers. I guess he had to do this by hand, so he probably did a lot of work. And I think he was an amateur mathematician. He's not that famous. I think he's only really famous for discovering these two sociable chains. But then there's also chains of length 6, 8, and 9. These were pretty discovered pretty recently, by the way. I think when I was a kid, actually, the only known there were no known chains of like 4, 6, 8, or 9 even. There were perfect numbers that were known. There were amicable numbers that were known. Not nearly as many of each of these. And the Poulet chains of length 5 and 28 were known, but no other sociable numbers I don't think were known at that time. So these were only pretty recently discovered. I guess in the computer age, which kind of makes sense because I think they were all discovered by computer. There's no other way that people know how to find them currently. And you can see that there aren't too many of these. I mean, at length 6, there's only 5 known chains of length 6, and the smallest one has the smallest element that's already in the billions, about 21 billion. There are 4 known chains of length 8, but the smallest number in the smallest chain of length 8 is over a billion. Then there's only 1 known chain of length 9. I guess the smallest element of that chain is just shy of a billion. It's about 800 million. And then finally, the Poulet chain of length 28 has smallest element 14,316. So I guess that one wasn't too hard to find. Seems kind of weird to me that there's a small chain of like 28, which is the largest known chain, and it was discovered before the computer age. Go figure. But I guess that's just kind of how the numbers work. And then, yeah, let me just say a little bit about Poulet chains. Here they are written now. So he discovered both of these chains in 1918, and like I said, the chain of length 5, the smallest element of which is 12,496, and then there's another chain of length 28, smallest element of which is 14,316. So, anyway. So that's really everything that's known about perfect, amicable, and sociable numbers. And oh yeah, and then I thought I'd show you this to finish. This is actually the picture that was on my cover slide on the thumbnail. And this is just the results of a numerical search. So this picture, I think this is a nice picture. This picture shows you all perfect numbers, amicable pairs, and sociable chains of numbers up to a million, with smallest elements up to a million. And you can see the two Poulet sociable chains; those are in blue. The big circle is the one of length 28. The little loop inside is the one of length 5, and then you can see all these amicable pairs listed out in green. Yeah, yeah, I'm not sure if the perfect numbers are listed here, but anyway, that you can get easily with a computer program, by the way. And I've written computer programs myself to look for smallish perfect numbers, amicable numbers, and sociable chains. And anyway, that concludes my video for tonight on perfect, amicable, and sociable numbers. Thank you for watching. Long live math, and I'll see you guys next time.